Hey, Unreal Engine artists and developers! Ever wasted hours manually editing properties for hundreds of assets? What if you could automate all that with just a few clicks? Meet a set processor, your new best friend for batch modifying uproperties, whether it has textures, mesh, sounds, blueprints, or any other asset type. In this tutorial, I'll show you how to set up smart rules that automatically apply changes on import, save, or with a single button. Let's dive in! Open Project Settings from the Edit menu and navigate to the Plugins category. Here you'll find the Asset Processor page. The top half of this window is Global Settings. We'll cover these later. They control plugin-wide behaviors like auto-apply triggers. Below that, the Rule Settings section contains the rule items array. This is your rule playground. Each entry in this array defines two things. 1. The filter, which assets specify folders, classes, or naming patterns. 2. The property actions, what to change. Add property overrides like texture settings. Now, let's create our first rule to modify textures. Look at the filter section. This is where we define which assets to target. First up, directory path. Click this combo box and you'll see three matching modes: recursive, equal, and regex. For this demo, we'll choose recursive and choose the game direction. This means it'll search through every subfolder under the game content. Next, package name. Open this drop-down. Notice we've got 5 options here: contains, starts with, ends with, equal, and regex. We'll pick ends with and enter _n, perfect for catching all those normal map textures. Now to asset class. This drop-down gives us two choices: include subclasses or equal. We want include subclasses, then we'll select texture 2D from the class list. This ensures we get every type of 2D texture, including any custom subclasses. With our filters set, let's actually modify some properties. Click Add in the Property Items array. Now this first combo box shows every editable property. They're displayed with both their technical name and user-friendly display name. Let's use the search box for faster targeting. Type LODG, and there it is, LODGroup. Pops right up. Select it, and we're ready to set the value. For the value, we could type World Normal Map directly, but watch this. Click the little property button to pop open the full editor. This gives us the exact same interface you'd see in the normal texture editor. Select World Normal Map, then close the pop-up. Let's add one more. Click Add again. Find compression stings and set it to normal map. Before we apply anything, let's test. See these 4 buttons in the rule header? Start with filter. This just shows us which assets match our rules in the message eleg. Go ahead and click it. And there we go, it's found all textures ending with _n. In the message eleg, you can click any asset path. The content browser will automatically locate that texture. Next, the check button. This is your safety net. It previews what would change without actually modifying anything. Click it now. Perfect. We can see exactly which properties will be updated on which textures. Let's verify the report by checking one texture manually. I'll pick this one. Currently its texture group is set to world. According to the preview, it should change to World Normal Map. And yes, the check is correct. This rule will update exactly what we specified. Now that we've confirmed the rule works, here's how you'll actually use this daily. Simply right-click any folder, even one not listed in your rules directory path directly, and you'll see all the same options: check to verify, modify to apply changes, or re-import to fully reprocess assets. The rules stay consistent, but you're not locked to specific directories. Now, let's execute the same modify action directly from the settings panel. Watch when I click modify here, the message eleg updates in real time, confirming all selected textures now have their LODGroup set to World Normal Map and compression stings adjusted to normal map. Just as we saw in the check preview, the texture originally labeled World has been correctly updated to World Normal Map, exactly as our rule specified. After modify, notice the asterisk that appears here in the assets title bar. This means the package has unsaved changes. Remember to use save or save all to confirm these edits. Now, let's test the import rule. dragging two textures into UE1 ending with _m, the other _n. The _m texture imports with default values. But the _n texture, our rule instantly applies. LODGroup becomes world normal map, compression changes to normal map. This confirms the rule triggers precisely on _n suffixes during import. Next, we'll configure a rule for skeletal mesh assets. Set the directory to /game/fp weapon with recursive enabled. For asset class, select skeletal mesh. Now, let's modify properties for all LOD levels. Add LOD info start. Allow CPU access and set it to true. Then add LOD info start. Allow mesh deformer and set it to false. Here, the star symbol means apply to every LOD level. Now, let's target only LOD 1. Locate the index input box next to the combo box. This controls which array element is modified. Type 1 into the index field. Now, only LOD 1 will set. Allow mesh deformer to false, while other LODs remain unchanged. Click Modify. The log shows LOD info 0 to 3. Allow CPU access updated to true. LOD info 1. Allow mesh deformer set to false. Let's verify the changes by inspecting the modified skeletal mesh. Open the asset and navigate to its LOD settings section. For LOD 0, allow CPU access should now be true. Allow mesh deformer remains true unchanged because we only targeted LOD 1. Now switch to LOD 1. Allow mesh deformer is false exactly as we specified in the indexed rule. Allow CPU access is true. Now, let's create a rule for SoundWave assets. Set the directory to game. For asset class, select SoundWave. Click Filter. We will see all SoundWave assets under the game directory. Now, let's narrow it down. Set package name to Regex mode. Enter the pattern, Fire, Weepian. This matches any SoundWave with Fire or Weepian in its name. Click Filter again. Now only matching assets appear in the log. We'll apply two standard properties. 1. Volume, set to 0.8, to reduces loudness uniformly. 2. Enable baked FFT analysis, set to true to enable frequency analysis. Then, the advanced part, replacing the frequency estanalyze array, will overwrite it entirely with for values. 100, 200, 400, and 800 HJ. Unlike earlier examples, this fully replaces the array, not just editing individual elements. Click Modify to apply changes. The log confirms volume and FFT settings updated on all matched sound waves. Frequency estanalyze now strictly contains our for values. Let's now explore a set processor's power with blueprint classes. This demonstrates how rules can modify both variables and child classes. First, let's examine our target blueprint. Opening demo actor blueprint, we see its core elements, two variables, demo boolean variable, currently set to false, demo transformable, default 0 values, and three components, DirectionalLightComponent, SkeletalMeshComponent, StaticMeshComponent. Now, switching to a set processor settings, set the directory to /game. For our target blueprint, we'll select demo actor blueprint directly. Notice this blueprint inherits from actor. We could alternatively select actor to find all blueprints inheriting from it, but that would return to many results. Instead, we'll use the specific demo actor blueprint for precise control. Clicking filter reveals both the parent demo actor blueprint and its child demo actor blueprint child. We'll modify both variables. First, add demo boolean variable and set it to true. Then add DirectionalLightComponent variable. Let's adjust its values, setting X location to 500 and Y rotation to 45 degrees. Clicking Modify applies these changes. Now let's verify in the original blueprint. DirectionalLightComponent variable correctly shows true. DirectionalLightComponent variable displays our new values. Now, let's modify the color of DirectionalLightComponent within our blueprint. Set directory to Game. For Asset class, select DemoActor Blueprint. This time, we'll enable Filter Subasset or Object, a powerful feature that lets us target components inside packages. With SubObject class, we can drill deeper. First, the rule filters for DemoActor Blueprint packages. Then, it searches inside them for specific components. Select DirectionalLightComponent to target only these light objects. Add the light color property. Set it to pure red. Notice we're editing, not the blueprint itself, but all directionalism inside matched blueprints. Click Modify. The log confirms color changes to embedded lights. And the directional light now emits red. For our final demo, we'll modify external actors in World Partition. I've selected a StaticMesh actor in the level. Its StaticMeshComponent currently has translucency sort priority equal to 0. Let's batch update this property across multiple actors. First, copy this actor's path. The path shows it stored in folder named FirstPerson Map under the external actors. In a set processor, set the directory to this external actor's path. For Asset class, select StaticMesh actor. Click Filter. This scans StaticMesh actors under the target folder. Enable Filter Subassets Objects, then set Object class to StaticMeshComponent. Now, add translucency sort priority and set it to 1. Click Modify to apply changes. Watch the original actor in viewport. Its translucency sort priority instantly updates to 1. The change applies to all matched components while keeping other properties intact. Let's conclude by reverting all test modifications. This ensures our project stays clean. Now, here's the real-world workflow. Right-click any folder in the content browser, select Asset Processor menu, click Check Assets by Rule. Instantly generates a report of all matching assets and proposed changes. Review safely before committing with Modify. After review, apply changes confidently. Right-click the same folder. Choose Asset Processor menu. Click Modify Assets by Rule. All configured rules execute simultaneously. MessageLog confirms each modification. Finally, let's look at the Apply Rule on Save feature, currently disabled by default for safety. When enabled, it automatically applies matching rules whenever assets are saved and generates a message log report. Here I have a texture currently set to World Normal Map Texture Group. Let's change to Character Group. With Apply Rule on Save enabled, let's save the texture. Watch, the texture group automatically reverts to World Normal Map. If you need to suppress notifications, use Enable Without Reports. It still enforces rules, but runs silently in the background. Perfect for established, trusted rules. And that concludes our asset processor demonstration. From texture adjustments to blueprint overrides and automated save enforcement, you've now seen how to standardize assets at every level. Remember, start with check, apply with modify, and when ready, let Apply on Save maintain consistency automatically. These tools will save countless hours across your production pipeline. Try creating your own rules and see how much workflow overhead you can eliminate. Thanks for watching and happy asset processing.